Hello everyone, I am Priyanshi Khanna, a data science and business analytics intern at the Sparks Foundation. Today I'll be sharing with you all the second task of my internship. So the second task was to make predictions using unsupervised machine learning. In this, we've been given a data set and we have to make a model over that data set and visualize it. So the raw data set is the iris data set, as you can see here. In this, we've got some species of flowers. There are 3 species. The first one is Iris setosa, the second one is Iris versicolor, and the third one is Iris virginica. Each species has 50 flowers, and each flower has a sepal length in centimeters, a sepal width, a petal length, and a petal width. So this is the whole data set, and we have to make clusters using k-means. So let's proceed. First, we'll import all the libraries like NumPy, which is used for scientific computations, and the pandas for easy data analysis. Then we'll import matplotlib.pyplot as PLT as the plotting interface. The fourth would be the data sets from the sklearn. So we'll write from sklearn import data sets. So actually sklearn comes with few small standard data sets that do not require to be downloaded from some external website. Another example of such a data set is Boston house prices, and one example is here, iris data set. So first we'll load the iris data set. For loading, we'll use datasets.load_iris, and we'll put this value into the variable iris. Then we'll convert it into a data frame using the pandas function dataframe, pd.dataframe, iris.data, comma, in columns we'll put the names of the columns, that is the features. So columns is equal to iris.feature names. To ensure that we have chosen the right data, we'll print the first 5 rows using the head command, df.head. So we've chosen the right data. Then we'll move on to finding the optimum number of clusters for k-means classification. To find it, we'll first choose the first 4 columns of the data set. Those are the sepal length, sepal width, petal length, and petal width. So these 4 columns we'll be working upon. For that, we'll use the ilog function, df.ilog. This means choosing all the rows and the 4 columns. We'll convert it into arrays through dot values, and we'll save all of this data into the variable x. So now we'll import k-means function of the cluster module of scikit-learn library using the command from sklearn.cluster import k-means. Here we'll make an empty list, WCSS. Actually, WCSS is a short form for within cluster sum of squares. It measures within cluster sum of squares. So actually it is the distance between the various observations. Then we'll run a for loop and ranging from 1 to 11, changing the number of clusters each time. And we'll assign, we'll use the k-means function. In that, we'll use init is equal to k-means plus plus. Now this is the initialization method of centroids, and it selects the initial cluster centers for k-means clustering to speed up convergence. Then we'll use n clusters is equal to I, that is the number of clusters. It changes each time from 1 to 11. Then we'll use n is equal to n underscore init is equal to 10. Now this is the number of times the k-means algorithm will run with different centroids. So it is 10 times. Then we'll use max underscore ITER is equal to 300. That is the maximum number of iterations we are allowing it to perform. And then the random underscore state is equal to 0, so that each time the answer comes out to be the same. Then we'll fit the model by writing k-means.fit x, and we'll append our WCSS list with k-means.inertia each time. Now k-means.inertia, it is the sum of squared distance of samples to their closest cluster center. It actually tells how far away the points within a cluster are. So we aim for a smaller inertia because we need a smaller intra distance. So now we'll run this command, and then to find the optimum number of clusters using a graph, we'll plot a graph, line graph, and we'll find an elbow point, because elbow point will be the point where the number of clusters would be optimum. And for plotting, we'll use plt.plot range 1 to 11 WCSS, and we'll put some title, elbow method, and we label the x-axis as number of clusters and y-axis as WCSS, and we'll show the graph. So here the elbow point comes at 3. So at the optimum number of clusters, the WCSS does not decrease significantly with each iteration. So the optimum number of clusters appears at the elbow point, which is 3 here. Now we'll apply a k-means to the data set, and we'll create a k-means classifier. This time everything would be same, just the number of clusters would be 3, that is the optimum number. Rest all would be same, and then we'll fit and predict the data. Y is equal to k-means.fit underscore predict x. Y would be the number of the cluster that we'll be choosing to put in. So there would be 3 clusters, 0, 1 and 2. Y represents the cluster label. Now after this, we'll start visualizing the clusters. For that we have to plot a scatter plot. So here we'll write plt.scatter x where y is equal to 0. So the first cluster whose label is 0, and this is the second thing is the column, again 0. Then again the first cluster 0, and we'll choose the second column 1. In a similar way, for the second cluster we'll put y double equal to 1 for the first column, and again for the second cluster y double equal to 1 for the second column. In this way we'll plot using C. C represents color. Each time we'll change the color to represent different clusters, and applying S, that is the size of the marker or the point. So it would be 50, or you can put it, if you want to increase the size, you can put 100, or any value could be put here. Then we label our clusters into the 3 species: Iris setosa, Iris versicolor, Iris virginica. After this, we'll plot the centroids for each cluster. For that, we'll use the function k-means.cluster underscore centers underscore all the rows and the first column, and again all the rows and the second column. So we'll plot it with the color yellow and the size 50, and we'll label it centroids. Now to describe the elements of the graph, here as you can see, the labeling at the right bottom corner. So we have Iris setosa, Iris versicolor, Iris virginica, and the centroids in different colors here. So this is the final graph that we obtain after clustering through k-means. Thank you so much.